Hello, everyone. It's my pleasure to introduce you all, Marcelo Simões Wolf, in this next keynote talk of SVR 2020. The title of his presentation will be Environment Understanding for HoloLens. For those who may know me, I am João Marcelo Teixeira, also known as Joma, and I will give a brief information about Marcelo. Marcelo Simões is currently a development manager at Microsoft, actually Microsoft's mixed reality group. From 2013 to 2020, he has been part of the computer vision group, and he has worked with many different topics in computer vision, embedded systems development, data science, computer graphics, and so on. Marcelo works with environment understanding, delivering, and advancing AR and VR products and technology on Microsoft. Some of the products that he is involved with, for example, were the head tracker in the HoloLens 2 and Windows mixed devices, as well as Azure Spatial Anchors. Marcelo joined Microsoft in 2006 as a software engineer based in Redmond, Washington. In 2013, he joined what later became Microsoft's Mixed Reality Group. In that group, he worked in areas like eye tracking, environment persistence, and head tracking. And subsequently, he moved on, this group moved on becoming the software engineering lead. And actually, now he's a manager, one of the managers of the group. So thank you very much, Marcelo. It's up to you now.
Thank you, João Marcelo. Thank you for the introduction. Good morning, everyone. Good afternoon, good evening, good night, wherever you are in the world. Thanks for joining us. Today, I'm going to be talking about environment understanding for HoloLens. I'm going to explain in a minute what that means. But before I do that, I would like to acknowledge the collaboration work that goes on to build a product like HoloLens. This is not only computer vision and graphics. This starts from hardware design, sensor, silicon, systems, computer vision, user experience, all those teams collaborating to creating a product like HoloLens. Not only that, but we are standing on the shoulders of giants. All the decades of research that have been done in all areas to get us to the point where we can build a device that really, truly enables a mixed reality world for people is just outstanding. And so it's a big effort, and I want to thank everybody in the community for enabling us and the team for coming together and building it. So everything starts with HoloLens. So let me take a moment to walk you through HoloLens 2. I have my device here. If you can see it, it fits comfortably in my head. I can adjust here. I have a top strap. I have a thing here. I can flip the visor. It has enough room for glasses if you wear them. You can just put in your face and wear like a baseball cap in a sense. It's designed to be immersive, so it has better field of view. It's designed to be comfortable, so you can wear it for hours. It's not heavy, and is designed to have good time to value. That means that I can put on my HoloLens, I can just press a button, and then I'm authenticated with my eyes. Holograms appear right away. I can place them in the environment. I can move around. I can use my hands. I can use my eyes. And it's just the time to value even for an application developer should be really great. And to build a simple to use device like HoloLens actually takes quite a bit of complexity. And so I wanted to show this exploded view of the device just to give an idea of everything that goes into a device like this. From clever battery placement to world tracking cameras, time of flight sensors, IMU, laser displays, custom silicon, custom DSPs, and everything coming and hinges and straps, everything coming together to build a device like this. And I wanted to give you an idea of what kind of innovation that really means to the users. This is something that I recorded on my backyard a couple weeks ago. And this is just to give an idea of, it's not only about enabling technology, but new ways to interact with computers. So here, now I can have a menu that pops when I raise my hands, and I can select my favorite color with my finger, and then I can go and draw something that I wanted to draw. And just like a whiteboard, I expect it to be there, and I can move around, and my drawing stays where it should be, what I expect it to be, because I want it to be world locked. And I'm going to use this word a lot, world locked. It's part of the magic of HoloLens, is to enable things to be world locked. It's not only about the display. It's about the understanding of the environment and the ability to place things in the real world. So environment understanding. There is a lot about environment understanding. Today, I'm going to focus on four things. And the main thing that I'm going to be focusing on is the head tracker for HoloLens. I'm going to talk a little bit also about Azure Spatial Anchors, about spatial understanding, and research mode for HoloLens. So let's go and talk a little bit about the head tracker for HoloLens. What is the goal of the head tracker? It's actually fairly straightforward. It's to enable world lock holograms for mixed reality. Its purpose is, in a sense, very simple, right? People expect, if you want to build a mixed reality world, people expect that holograms behave just like real world objects. And that means that they have to stay stable with the world. They have to survive across space and time. They have to be stable and all of those things. And so there is a lot of consideration that goes into those things. But first, let's start with a little example here. This is a sort of like a puzzle game on HoloLens. And so you can see here, I placed that in my house, and I'm trying to look around for switches and things to go and solve this puzzle. What I expect is that, just like a board game, this is a 3D board game in a sense, I can move around and it stays where it's supposed to be. You see, there is no jitter, there is no shifting, there is no glitch. So how do we do it, right? So what can we do to deliver those world lock holograms? Today for HoloLens 2, those are the sensors that we have available. We have 4 tracking cameras. Two of them are a stereo pair. We have 1 IMU. We have an RGB camera. We have a depth camera. And this is what we use to do our environment understanding in general. Now, this is not a one unidirectional process, right? So, like I said, takes huge collaboration to build a device like HoloLens, present in future and past devices, which means that the computer vision challenges inform the hardware decisions and the sensors and hardware limitations inform how we're going to architect and design our computer vision systems. So it's a collaborative effort so we can together address all our design considerations and constraints. And this talk, in a sense, is about walking through what it means to build a system that works on a device like HoloLens, as opposed to a system that is going to run on my laptop. And how does it affect the design and everything that we have to take into account. So I'm going to spend a little more time talking about the design considerations, because they're really key here. If you're trying to do environment understanding for autonomous vehicles, or I don't know, for a robot, they may have different considerations than the things that we do, depending the problem you're solving. And so in order to build a really simple system that works well, you really want to leverage your constraints in a sense. So what are the things that we consider when building something for HoloLens? Well, here are some of the top ones that I listed. We need a low power device. Our goal is to make HoloLens as smallest device that we can build with the longest battery life. And so we also care deeply about accuracy. The accuracy and stability of a head-mounted display system is very important. We don't want people to get sick. And even beyond sickness, if things are not stable, the the feeling of a mixed reality is just not there anymore. When you realize that the holograms are now real, and then a lot of the experiences fall apart. In addition to that, the system needs to be scalable. We built HoloLens to be a generic device. They can be used in a wide variety of environments, of all sizes, and anywhere. For example, I could go and use HoloLens in my office, and I can go and drive home and use HoloLens at my house. And the system should just work. I shouldn't have to swap things or delete data or manage anything. This system should just work at scale. In addition to this, we're gonna drill in those two last ones as well in the end. Persistence and sharing are pillars of mixed reality experiences. If you want to have a mixed reality world, world objects, the real world objects, are not transient, as in like as if you put something on a table and you come back the next and you go to bed and you come back the next morning, it should still be there. It shouldn't have disappeared because you turn off the device or you slept. In addition to this, real world objects are available for everyone to see if you want. And so you're going to realize that the first thing that people do when they put on a HoloLens and they feel dazzled about the mixed reality world is that they go to the person right next to them and they're like, do you see this is amazing? And if the other person cannot see, then the mixed reality world is just for the one individual, which is not as interesting as a shared mixed reality world. And those considerations, they actually reflect into the way you architect our system and the way we do our engineering deeply. For example, even small things like I want to make a change in the code base. When you make a change, we need to have affordances to validate what is the impact of power of your change, what is the impact of accuracy of your change, how does your change affect our scalability, if your change will allow us to be persistent, and if there is anything you change that is preventing us to do accurate sharing. Like all of those things, they have to trickle down into every single action that and design decision that we make in our system. And one of the main ones is the fact that in order to really do all those things, we have to make a system that breaks beyond, that needs to be decomposable. Having a monolithic system does not address a lot of those things there. And so one of the things that we do is that our system is broken down into components and levels and even computing entities. And we're going to go and touch some of those things. There are three main components that I wanted to talk a little bit about today, just to give a taste of what it means to each one of them. They are the visual tracker, the state estimator, and the mapper. And so we're going to talk a little bit about every single one of them. Before we do that, I wanted to give just a general feeling about what does it mean to do head tracking, like what is the system actually doing at the high level. And this video is trying to give that idea. So you turn on the system, you're going to find out that the way the particular system is doing head tracking is finding interesting landmarks in the environment. It's tracking them over time, over frames. It's either finding or not finding them. Is using those measurements to estimate accurate positioning. You can see that I can move, I can rotate. I don't have to. I can lift my hands. It needs to be resilient to people. It needs to be able to manage data in a smart way, so it doesn't run out of space or memory, and all of those things. The first component is the visual tracker. And it is really a simple component from an architecture standpoint. Its job is to take some camera feeds and to do visual tracking. And in our system, in HoloLens 2, the visual tracker runs at 30 hertz. And there is a frame tracker that is essentially estimating poses from a local map. So it needs to track in some sort of map. Like I mentioned, in order to make a scalable but yet low power device, you have to create those layers of like data and responsibilities. And the front end has what I call a local map. It has a smaller version of the world because it needs to run really fast and accurately. and it has just the data that it needs around you to be able to give you precise positioning. In addition to this, this local map data needs to come from somewhere. And it comes from many sources. It comes from the disk, it maybe come from the cloud, but there is a key component that it runs as part of the visual tracker, which is almost the fail-safe component, which is the keyframe creator. That is, in absence of map, where you go into a completely new environment for the world, it is there constantly finding landmarks, estimating the points positions, and creating a new map so the tracker can keep tracking at least on a local coordinate frame. This is what a frame tracker sees. And so the previous video when I showed the tracker, that's more like our top level view. This is what a frame tracker is actually looking at. It's finding landmarks at different scales, is aware of the apparent appearances of those landmarks, and is trying to reproject and re-estimating what they are. The next box that I wanted to talk a little bit about is the state estimator. And that comes from the fact that at the end of the day, you have to have really frequent pose estimation for a head-mounted display, and it's stable. So the state estimator is a component that we have that takes IMU and visual tracker poses as measurements and is generating poses at 240 hertz. The way to look at this component is that it's taking information like gyro, accelerometer, visual poses from the frame tracker, and motion model, and fusing them to estimate things like pose, velocity, acceleration, and gravity. Here is actually on the side a plot from some of the states that our tracker estimates at real time. This is from a real HoloLens device, and you can see how our state estimation evolves over time and gets updated as the system learns more information. And the last component that I wanted to talk about is the mapper. And the mapper is responsible for mapping the environment. As you're walking around, it's estimating more geometry and tying things together and really understanding the structure of the environment. It actually has two categories of problems, in my view. There are map management problems and responsibilities, and there is data management. And I want to talk a little bit about them. The first one is about keeping the actual understanding of the environment and the map. And something to realize is, again, coming down to the scale, is that the map is not like a fully connected entity. You can, like I said, you can go to the office and map your office and just use the HoloLens, and there is a little like map, if you will, of the office. And you can drive home with the HoloLens off, and then you have holograms in your house too. And those environments may never be connected, or maybe someday you're gonna walk between them, and then or HoloLens is on, or there's enough data in the world collected that we can put them together as in like, hey, I know exactly how one can go to the other very precisely, but there is no harm in if they aren't. There is still a single map of the world, even if there are gaps. And that is actually, in a sense, good that we design a system with that in mind, because in the world where you have to have a low power device and yet you want to have world scale holograms, you can really leverage this fact to do smart decisions. For instance, on the device itself, things don't have to be globally consistent. What I care about is about what the user sees right now. So if you are in the office, optimizing poses and holograms in your house can be considered a secondary task. If I have time and space and power to do it, I can do it. If I don't get to do it, then it's okay, because the user will never see this. And by the time that the user maybe gets home, then I'll get to it. The second category is data management. And again, when you're talking about scale, you have to distribute not only your compute, but your data across many entities. Each one of them will have a different piece, a different level of abstraction, and they all need to work together to go and deliver this. So there is SOC side, there is disk, there is our HPU, which is a custom processor for environmental things, and there is cloud. And a lot of engineering and architecture works goes into deciding of like how do we go and architect this multi-layer system to enable a world scale tracking and environment understanding. And each layer has a relevant piece of information or a submap or a piece of that information that is working on right now in order to orchestrate the entire world map. And this here is just to add some more color to the mapper, right? So to kind of like summarize what we have there, the mapper has what I call in here an active map, which is a piece of the world that it matters to you right now, and it's going to do map operations on those things like optimization and bundle adjustment, data association to go and expand the map. Is going to do relocalization to put together two different maps that we never had a correlation between, and now we are tying the world together. And it needs to do pruning because at many layers across the stack, they have limitations, and deleting old data or redundant data becomes an important task to have a healthy system and to have bounded CPU and disk and power usage. And this mapper has to talk to some storage service, which depending on where you are, is going to have a meaning. For example, if you are in the little HPU processor, then your storage service may be the entity giving you more map information, maybe on the sock side or disk. And if you are on the sock side, the storage service giving you more map information may be coming from the cloud, and so forth. So it's a highly distributed, and not only distributed in the cloud, but it's distributed between cloud and edge, and even in the edge, it's distributed across DSPs and SOC and disk and memory, and all of this need to be thought through in management. So it becomes a problem, engineering problem on top of a computer vision problem. So hopefully that gave you some idea of like what the impact is to build such a constrained and scalable system. Now I'm going to take a little segue here to talk about Azure Spatial Anchors, because it is an evolution of the head tracker topic in a sense. So when people they put on the HoloLens and they get immersed in the mixed reality, they quickly find out the collaboration and persistence are key pillars. And so in order to address this, we created something called Azure Spatial Anchors. And I just wanted to show a little video to give a hint here about Azure Spatial Anchors. So the key takeaway here that you may notice is that it is not only about HoloLens. And with our objective to really enable mixed reality for the world, we can't be constrained to a device. Like we enabled phones to also go in and peek into the mixed reality world, right? To enable those experiences. Is the immersion factor of a phone as great in interaction models as HoloLens? No, but we want to enable access to mixed reality for all experiences, anything that we can. And if we had to build a world scale anchoring system for HoloLens, and we can do for other platforms, we will do that. Before we get there, I think it's worth spending a couple minutes talking about anchors, because it might not be clear for everybody. So an anchor is a common frame of reference to place digital content in some physical location. So let's say you are here in the living room and you like to add the hologram there and you like to stay there. What happens in reality is that we are constantly mapping and understanding the environment. And because we can do that, that allows us to enable you to drop some content there. And this content is going to stay and persist and be shareable over time. Here is what that means. Here's a video that shows that. This is on the phone. So you pull up your phone and you have those holograms. They're spheres. They're not very interesting, but we're trying to show you how we can retrieve it. And let's say you you really want to drop a hologram at the new location. And so you went there and you added this new sphere that it did not exist in the world. And you're walking around and we understanding the environment all the time like we do. And suddenly your hologram is like placed, right? And you can see that locally. And now you're going to decide to, okay, I'm done with this. And then another person comes along with a different phone and they turn on and they have Azure Spatial Anchors. You're going to see that the moment that they walk into the environment, they can retrieve the new sphere and then all the previous ones. And this is, again, you're enabling different devices to go and have a shared mixed reality world. So what is Azure Spatial Anchors? It's essentially a service that enables multi-user mixed reality experiences. It does persistence across devices and time. And it has a world scale. This pictures here, this is actually the Microsoft building, Studio A. And this is not even like the scale that Azure Spatial Anchor has a problem with, but it's just to exemplify that a building can be easily mapped with this system. And you can place holograms anywhere and retrieve them over time, and the system just works. And it's something that works across devices and platforms. Different levels of quality depending on the platform, but it is there, and you have a way to pick into the mixed reality world and experiences. And the best thing about it is that you can give it a try. So even if you don't have a HoloLens, like I said, you can go to the Azure page, mixed reality and spatial anchors, and give it a try and prototype with even a mobile device today, and start to experiment with mixed reality yourself. The last topic here is scene understanding. And this one is a bit different from the other two, and is just to exemplify our work into trying to make HoloLens time to value great. And this is about enabling app developers to build natural and immersive and interactive applications. When we released HoloLens 1, it was not intuitive to write mixed reality apps that were natural to interact with over the real world. This is kind of like what we provided. You can see here that you get a mesh. The walls are not flat, the ceiling is not flat, the floor is not flat. There are many holes around that you can maybe fill if you are walking around and scanning to the best of your ability. There is something that resembles a chair, but as an app developer and you just get this mesh, it is very hard to make intelligent use of this. Not with a lot of work. And the goal is to actually have a system that gives you an understanding of the world. And so this is what we're enabling with the spatial understanding. We have object decomposition. We have watertight manifold of the environment. We have semantic completion, so you don't have to fill all the holes yourself. We have planar surfaces that will be planarized for you, semantic certification of like what is a wall, what is a ceiling, and ultimately still have the word mesh. And this is a demo on HoloLens running in real time. You can see that the floor is flat, is labeled, the walls are labeled as walls, and the chair has a label as well saying, this is a surface and you can place a hologram here. And we're doing more and more work there and enable more understanding of the world. But with this kind of abstraction level, now suddenly writing apps becomes a much easier exercise, much more like writing a game that you have designed the level. And that's our goal. And last but not least, a lot of the things that I showed here is we implementing environment understanding to enable use of HoloLens for app developers and experiences and all of this, which is great. I wanted to also talk about how, in addition to this, we enable people to experimenting with understanding of the world themselves, right? So HoloLens has a research mode that exposes the raw headroom tracking cameras, the depth cameras, Excel, gyro, magnetometer. And so people that want to push the envelope of environment understanding, either by bypassing our systems and doing their own, or by augmenting our capabilities, they can do that. They're enabled to get this data and then to do research and experiment, to do demos, anything that they want. We embrace that. And that's all I had. Thank you, everybody, for listening. I'm happy to answer questions, but I wanted to give everybody a little of a taste of what the work we do in environment understanding in HoloLens.
Thank you very much, Marcel, for the amazing presentation. I believe we already have a question from Fatima. So let's start with this question. She's asking how the persistence is made on HoloLens. If it's really necessary, for example, for the person to be connected to the internet during the use, or how this work?
Um, it depends of the levels of persistence. So we try to enable as much as possible without the use of internet. So, for example, if you use a HoloLens today, you don't even have to connect to Wi-Fi. You can drop holograms, and you can persist them, and you can retrieve them. All of this works. Um, if you want to do sharing, and then that becomes harder. We actually provide some APIs that allow applications to extract some information and send to another HoloLens to do more like a peer-to-peer. Uh, that it doesn't achieve the same level of quality and reliability as what we can do when you augment the device with the cloud. So it's a co-design. We are better with the cloud, if you will. It is not a necessary thing.
And what about the requirements? Does it need a very powerful internet connection?
No, it doesn't. You saw that the phone was sharing holograms, um, and so it is not very chatty data. There is a amount of data that is transmitted, but it tends to be pretty reasonable. If a phone can do it over a phone network, then most of the devices that are not phones can also do it. So it's something that we, by the way, work very hard to improve over time. But so far, it seems to be good enough for most of the experience out there.
Nice. I have another question. This question is related actually to a trend that we have observed in the past 21 years of SVR. We have made a work that analyzes the past publications. And what we observed is that there's an increasing trend on works that are performing user studies and validation and statistical analysis and stuff like that. So as you said, HoloLens is a product that can be and should be used by different people. And how do you can guarantee, for example, that people do not get sick or that's gonna work in different light conditions? Can you talk a little bit about the test?
Yes, absolutely. The only way that the way that we use it, in my opinion, the only way they can effectively guarantee this is essentially by having a lot of data, conducting a lot of user studies around what does it mean to get sick, um, what is the distribution across the population. Not everybody is the same, and running a lot of people through comfort and sickness studies and whatnot to get hard data about the requirements is important step, and we do that. Uh, in regarding to like accuracy and what do we do, like we collect a lot of data, not from users. We have a team that goes around the world collecting data, visiting places, visiting light conditions, kinds of environments, North American, European, South American, and we have a huge corpus of data that we then run every single change that we do against the data. Every single change that is done on the HoloLens goes through a set of environments that covers a range of conditions, occlusions, environments, and everything. And we, in a sense, is our secret sauce that we can drill down into exactly what changed and how, and go in deep and analyze this. And in a sense, that is actually we spend a lot of time on as we're trying to make a generic system, because oftentimes people produce some computer vision applications that are very narrow in their scope, and that's okay. That is good for a lot of applications. but things tend to become increasingly harder when you're trying to cover a wide range of environment and conditions. And the work is really to go and find all those conditions and work hard to make your system resilient and extend your system capabilities to handle all of those.
Nice. We have one more question from Huva. The person is asking about the scene understanding. So, is this the primary source of data, the image from the camera is capturing, or the 3D map points, or both?
It's the primary the
The primary
primary
source
source
of
of
data.
data. So every single piece of data is used. Um, so the answer to this is that every single sensor that I showed, the world cameras, the depth camera, and even the subsystems, in a sense, for example, if all the systems that we built, they talk to each other. And so if I was able to retrieve the pose of the device, or gravity, or what else, that can be made available to any other component, in a sense, to go and utilize that information. So all the subsystems are sharing information. Every single one of them is responsible to understand something about the environment, and another component may make use of that information.
Okay. We have another question from Salvador Agati. He's asking about how do you deal about private data? For example, you are capturing different information from camera and stuff like that. How do you deal with private data from hand tracking, for example?
So all the information that we process, all the sensor feeds and whatnot, they are not sent anywhere. They go through a strict Microsoft process of privacy. They are processed on device, and they are no data that is necessary to be persisted to enable any experience is not saved. First, there is no automatic data collection of any sorts. And for some of the data that needs to be persisted, in a sense, like I said, like the map of the environment and so forth, though this data is either obfuscated or and always saved into the context of a user on the local device. And if you go and choose to use a cloud service like Azure Spatial Anchors, and then there is also, if you go to the documentation, there are also guarantees about we extracting information that does not contain anything on the environment that is identifiable. We extract high-level representations from the environment. We don't extract imagery or anything like this. No personal information is ever sent, and whatnot. And the user is always in control of their account. They can see all the data, they can delete the account, and so forth.
Okay, I believe we have one more question. I believe you know this guy, Sergio Clemente Filho. And the question is, how do you foresee the experience of HoloLens changing as the device will have more power, more CPU, more memory, disk, etc.?
Um, the experience changing over time. The way I see it evolving is just having more advanced interactions made easy. And so again, like the you can foresee the device is going to get smaller, right? That's obviously we're going to try that. Battery life is going to be better. It's going to become more immersive and more advanced interactions. For example, if I take environment understanding, what I showed with like scene understanding is a good example of that, where before you had no understanding, and you're on your own to try to make sense of the world. And now you can get the walls and the floor and surfaces, and you can hope that first this works way more reliably anywhere, everywhere at scale, and you get better understanding of like, hey, this is this kind of object, and things like, hey, I can actually drop a hologram on this chair, and if I want any other chair like this to also have this hologram, then I can do so. And just more advanced environment understanding will allow us more high level reasoning for apps about this, and that will just result in just easier to use and more advanced capabilities for applications.
Okay, more questions. Uh, how are you managing the cleaning issues due to coronavirus, for instance, when you switch between users using the same piece of device? This question was from Master Pinho.
Within the team, is that the question? I'm not sure. Within the team, Microsoft is closed, so we're all working from home. Everybody has their own HoloLens device. Uh, if I've seen partners using that in their environment in countries that are more open than where we are here right now, I see people wiping down their devices. Um,
Have you ever thought about creating an accessory for instance, like a face shield to couple to the HoloLens?
I actually don't know the answer to this question. It may be that it's being considered. I It's not something that I'm aware of right now.
Yeah, I'm just kidding. Let me,
You joke, but it could be that it's actually
yeah,
a need for that.
yeah. Actually, it looks like a face shield. You just have to add the protection. I believe we have our last question. Um, it's a question from Huva, and the question is: do you see the evolved version of HoloLens replacing mobile phones in a near future, or replacing our primary device, which is the mobile phone? If yes, when do you envision that?
Um, I don't know. Um, replacement is a strong word. So my personal view is I don't think it competes with phones. I think it provides experiences that are way deeper than you can ever get on a phone. So I think phones still are pretty powerful from a lot of other applications. I guess what I could say is for a lot of specific applications of the phones, it could be that is actually replacing it. For example, if you have a device that is mobile and it is easy to use, like HoloLens, or future versions, then, for example, maybe mobile gaming makes more sense in a device like that. Or visualization of data that a lot of people even do on their phones today. It becomes very easy to just to put this glasses, this goggles on, and then just see this data in a more rich and bigger screen, automatic bigger screen way. And so there are a lot of applications that will definitely switch from mobile devices into HoloLens. They don't have to fight though, as in like we're enabling mobile devices to peak in the mixed reality world. It's just that HoloLens enable a superior experience in a lot of kind of interactions.
Okay. Uh, I believe we do not have any more questions for the moment. For you to know, Marcelo is also on Huva. So if you guys want to talk to him or send him more questions later, you can access Huva and his profile. You can have a chat with him, of course, if he has time. And so basically, I would like to thank you, Marcelo. Thank you very much for the presentation, for being here with us virtually, of course. And yeah, that's it.
Thank you so much for having me, and it was great speaking about environmental understanding and giving people a peek of the work that we do.
Yeah, our pleasure. So I would like to give the attendees just information here. Let me show. Where is it? Yeah. Yeah. I will place above a little list of links of activities that we can do right after this keynote. So you may see the links and you can visit some virtual museums and go to activities together. Okay. Thank you very much. See you.